சார் சொல்லுங்க சார்.
HR விஸ்வகர்மா வந்து எங்களுக்கு பீஷ்ம பிதாமா மாதிரி CSI வெள்ளூருக்கு.
கண்டிப்பா அவர் இல்லாம எப்படி நடத்துறதுன்னு தான் ஃபர்ஸ்ட்.
அப்படி அவர்தான் பீஷ்ம பிதாமா. அவர்தான் எல்லாமே எங்களை ஸ்டார்டிங்ல இருந்து ஃப்ரம் தி ஸ்டார்டிங் ஆஃப் தி சாப்டர் மெம்பர்ஸ் மொபிலைஸ் பண்றது எல்லாமே அவர்தான்.
ஆமா ஆமா கரெக்ட். அதனால தான் அவரு PRK சார் இஸ் ரியலி சப்போர்ட்டிங் அஸ் அண்ட் போன தடவை கோயம்புத்தூர் சாப்டர் இனாகிரேட் பண்ணதே அவர் தான்.
அது ஓகே. பட் VITல வந்து ஸ்டார்ட் பண்ணதே இவரு ஸ்டார்டிங் எல்லாமே அந்த ப்ராசஸ் எல்லாமே வந்து எனக்கு கத்து கொடுத்தது எல்லாமே இவர் தான்.
குட் குட் வெரி குட் சார்.
ஓகே சார்.
ஓகே சார்.
மான்யா சார் ஸ்டார்ட் பண்ணிடலாமா எப்படி சார்?
சார் 703 தானே சார். இன்னொரு 2-3 மினிட்ஸ் வெயிட் பண்ணலாம் சார்.
ஃபைன் சார் ஃபைன் சார். ஓகே ஃபைன்.
என்ன சரவணகுமார் சார் ஒரு 5 நிமிஷம் வெயிட் பண்ணலாமா? இன்னும் கொஞ்சம்
let us give couple of minutes for others to join.
ஆமா கிறிஸ்மஸ் டைம் வேற இது வேற. Anubhav has joined, Vaibhav has joined, Anya is there, important person, Tejas is there, good.
Okay, ma'am. Sir,
Okay.
fine. Manya? Yes, Manya.
Hello. Um, Good evening, everyone. On behalf of CSI Region 7 student chapters, I extend a very warm welcome to our distinguished guests, respected faculty members, student leaders, and all participants joining us today. It's truly a pleasure to see such an enthusiastic gathering for the Student Led Development webinar, an initiative designed to bridge the gap between academic learning and real world industry practices. Sessions like these play a vital role in preparing students for the evolving demands of technology landscape. I hope everyone's doing well and ready for an insightful and engaging session ahead. The Computer Society of India is the largest professional body of computer professionals in India dedicated to advancing knowledge, innovation, and research in the field of computing. CSI actively nurtures student talent through technical workshops, webinars, hackathons, leadership initiatives, and meaningful industry interactions. Now, allow me to introduce myself. I'm Manya Kukreja, Vice Chairperson Management, CSI-VIT Vellore. It's my privilege to host today's session and coordinate this important discussion on cloud dependency and DevOps practices, a theme that forms the backbone of modern digital infrastructure. Today, we are privileged to welcome our guest of honor for today's webinar, Professor H.R. Vishwakarma, an accomplished professional recognized for his contributions to the technology driven innovation and exceptional student mentorship. Sir, your guidance has consistently inspired students to think beyond the classroom and explore impactful technological solutions. We're delighted to have you with us today and invite you to address the gathering.
Good evening, everyone. I'm very happy to be here. And this is basically very kind of personal and emotional kind of to be on the platform because this is very, very close to my heart. And CSI chapter, we started in 2004 and 2005 academic year. And this has got support from VIT management, which has actually sponsored 25% fees of the life membership fee for the faculty, provided all the facility. So this was, I think, most easiest way to create chapter in the remote area like Vellore, because Vellore is different from Chennai or Bangalore, big cities where we have a lot of financial kind of support available. But city like Vellore, without VIT management support, it should have not been possible for us to start a chapter. So VIT management, we should really, I always remember, and my members of the CSI Vellore chapter, they always remember that VIT management was very, very generous, supporting the financial grant of 25% and providing all the facility for the chapter to operate here. And a chapter, actually speaking, it has started its activity in August 2004, though officially it was inaugurated in 28th February 2005. A couple of months ahead of that, chapter started functioning. First meeting was held here in August 2004, where we invited all the CSC and IT HODs from Vellore region. And that event was supported by NESCOM Regional Office, Chennai, and TCS. And after that, formally we proposed our chapter formation to the headquarters. Headquarters was very, very kind enough to approve that formation of chapter here in very, very less time. And on 20th February, that is India's National Science Day, the CSI Vellore chapter was inaugurated by then Vice President of CSI, Mr. P. R. Rangaswamy, Regional Vice President, Mr. Satish Babu, in the presence of then Vice Chancellor, Dr. Radhakrishnan, and then Registrar, Dr. Aditan, and many other senior people. So this was the beginning of the chapter, and all the professors of computer science, engineering, information technology, and computer application, three departments, they have given us full freedom full autonomy and full support to start the chapter. Otherwise, it should have not been possible to start the chapter in that less time. And all these senior people from CSI, Mr. P.R. Rangaswamy, then Mr. Edar Mohan from Chennai, and Mr. Satish Babu from Trivandrum, Mini Vonanath, Mr. Sabhapati for a Bangalore chapter, all of them, they have been very supportive to us. They have really kind of guidance they provided. They have provided all support, and we could do a lot of events. Almost every year we could do some 4 to 5 events every year. So that was the kind of things that we had made kind of progress, and our VIT student chapter also was started within less than 2 months. I think it was inaugurated on 9th April 2005. Within 2 months of the formation of a professional chapter, we started a student chapter. So VIT is the only institute in the country which has both the chapters, professional chapter for faculty members and other working professionals, and for students. This is the only institute in the country which has hosted both the chapters, professional as well as student chapter. So this is a unique distinction of VIT. Thanks to the management generosity and kind-hearted support to CSI. And we have been doing many events. December 2005, we hosted first time a national workshop on data warehouse and data mining and business. It was well attended. And subsequently, next month, we had another event, a national workshop on natural language processing. March, we had a national workshop on distributed computing, grid computing. And so on, many events we have been doing it. And we proposed, because we don't have any education research conference in the country. And our chapter proposed a conference, new series on conference on education research, and CSI Division 5, that is for education research. And we hosted first event in VIT. It was happening in March 2008. There was first event happened in India on computer science education research. And subsequently, it was taken to Cochin in 2009, Guna in Madhya Pradesh in 2010, 2011 it was taken to Allahabad, 2012 it was taken to Faridabad, and so on. So this is the kind of remarkable work we have done in VIT under graduate chapter and under student branch activity. And this would have not been possible without the dedicated support of our faculty colleagues. I cannot tell everybody's name, but I remember some of the people's name actually. So dedicated they have been working with us. And Professor P. Kalyanaraman is one such person who was also with me as a founder secretary. And he did so much work. He was driving the membership development through the VIT campus and other college in Vellore. And he has created almost around 80 or 90 life members within a very short time. And similarly, we had our Margaret Anushya madam. She was the first student branch counselor. So we have many colleagues who have been working, but I cannot tell the name of everyone because it would take a lot of time. And this was the kind of, I was very fortunate to have such a wonderful colleague and devoted people who made me to really work for CSI. And CSI Value Chapter was a kind of strong foundation for me, which has given me a lot of confidence. It has given a lot of confidence that I could really take up responsibility at the national level. And that was basically given me the opportunity to work with the national level. And I was the national student coordinator for 2006-2007. That was the position created first time. And then I was chairman of education research for the 2007-2009. Then again, I was second time national student coordinator for 2009 and 2010. Then I was honorary secretary of the CSI national level, 2010-2012. And many positions I have been getting thanks to the support of CSI Value Chapter members and management of VIT. And I was also working as nomination committee member for 2013 and 14. And next year, Professor P. Kalyanaraman also become the national level nomination committee member, 2014-2015. So that way, why I'm telling this all these personal stories, because the student may think that CSI is just a forum for having some extracurricular activity. It's not the case. It is doing much more than that. See, I was in Bangalore chapter for several years, almost 1 decade. I was there actually as part of volunteer and part of management committee. But in Bangalore, I should have not maybe become the founder chairman of Bangalore chapter. It was not possible. It was founded long ago. When I came to Vellore, I had the distinction of become founder chapter chairperson. Nobody else can get that position. Because that was possible because of Vellore being a small city and we have very generous support of institute like VIT. So that was not possible in any other city, but here it was possible. So I have my own example with how much I got benefit from being a member of CSI, working for CSI. The students should not think that as long as they are a student of VIT and they should only be member of CSI, you should become member of CSI and once you join the company also. And it gives you a lot of mileage, a lot of advantage, a lot of visibility, a lot of support is available with that. So with, I don't want to take more time because it has was given 5 minutes and I think I have already exceeded. I had a lot of many opportunity in the sense CSI has made me to represent themselves in many things. Like for example, all Association of Indian Universities, they had an annual meeting in Chennai, Anna University in 2007, I think November 2007. And I was representing CSI, where all vice chancellors are there. I was not vice chancellor, I am a faculty member. But CSI made me to go and attend that event. Similarly, I was also representing CSI in Global Investor Meet in Madhya Pradesh, Khajuraho. That happened in 2010, October 2010. So these kind of opportunities are available when you are associated with a society like CSI. And CSI is our own society, and it has done so much service to the industry, to the general society, to the education institute, R&D organization. CSI is a very great platform, and we should continue really maybe contributing to the CSI and making many things. For me, I can submit my maybe talk. I can just say that for me, CSI is a forum, is a platform to create value and then share that whatever outcome of the value and innovate. So CSI for me is a creation of value, sharing the benefit of the value and the innovation of those whatever we done it. So CSI stands for me basically create, share, and innovate. With this, I want to thank all of you and inviting me to be part of this. It's a really nice recollecting of my memory for several decades, almost 2 decades. I think CSI chapter was started in 2004-5, so more than 2 decades. So it is a long journey. I'm very happy that all of you are working great service you are doing to society, and many more things you are going to improve it further, and you are going to take a chapter to the greater heights. What we could not do it, you are going to achieve it further. So thank you so much.
Thank you so much, sir. We are delighted to have you with us today. We are equally honored to have with us our chief guest, Mr. P.R. Krishnan, a seasoned industry leader known for his strategic insights in technology, leadership, and large-scale digital transformation. Sir, your experience and perspective will greatly enrich this session. We are truly grateful for your presence and respectfully invite you to address the gathering.
Thank you very much. It's an honor to be the chief guest for this session, a session whose subject is very close to my heart because I have been associated with this space as well as with agile DevOps and automation, AI, and all the technologies we talk about during my service in TCS. So I was heading the cloud cybersecurity, automation, and AI services during the tenure of almost 2004 to 2020. So it is I think I went through the stage when cloud was just creating the change, which was very much required from an infrastructure perspective. The biggest change which cloud brought in was agility and scale. And from an enterprise perspective, it became attractive because it kind of moved capital expense to operational expense. That's a big deal for any enterprise. And the next one is, of course, cloud democratized compute. Now that was computed, that means people had access to compute, and it was also accessible to any scale. So this also brought in the characteristic what we call as elastic auto-scaling. The 3 platforms like AWS, Azure, and Google made high-performance computing available for everyone, and at the same time even for the individual, it provides them flexibility. They can increase their capacity whenever they want. They can decrease it whenever they want. That kind of flexibility was offered by cloud. So it created a new platform for what led to a revolution in software development, which is now called as Agile DevOps, which is the other topic which is going to be covered in this session. So I think we are addressing the right areas, because as we go through this cloud era followed by AI and other new technologies which are coming at a very rapid pace today, it is important for us to understand that there is an overarching security requirement which makes us think about how do we create sovereign cloud, a sovereign data center, sovereign LLMs, sovereign AI, a whole bunch of things where we can protect ourselves as a nation from any discomfort we may feel from other parts of the world. So I think we are at a very critical point in the evolution of these technologies, and young students like you will have to be conscious of the era we are entering, which is driven by AI, but which also has to have some process discipline, which is where Agile DevOps made a big impact on how we were developing apps, which changed the face of software development. I will stop with this brief introduction. Thank you so much for inviting me to this forum. I look forward to the speech by Mr. Tejas Ghatte. Thank you.
Thank you so much, sir. We are truly grateful for your presence. Without further delay, I now invite Tejas Ghatte, Vice Chairperson Tech, CSI-VIT Vellore, and Software Developer Intern at Maxim AI, to begin the technical session on dependency of cloud services in today's world and best DevOps practices. We encourage all participants to actively listen and note down their questions for the Q&A session that will follow. Over to you, Tejas.
Good evening here. Thank you for being here for the session today. I'll just start with it now. Let me share my screen. Is my screen visible?
Yes.
Okay. So first I'll introduce myself. Tejas Ghatte. I majorly work in Golang and backend development. And so a lot of my work had revolved around just using cloud, breaking it and learning again. So I would like to share this experience with you and some important pointers. So let's start. So let's get the context ready for today's session. First, we'll move through the basics. Then we'll learn about the incidents, what happened recently. And then I'll give you a demo with containerization, Docker, and all the tests that we have developed. So today we'll just not talk about what happens when cloud does right, but we'll talk about what happens when it goes spectacularly wrong. So before the cloud, let's say in earlier days, if you had to deploy a big application in the internet, you had to act like a construction company. You have to buy physical servers, rent a room. You had to install massive air conditioning unit to keep it cool. And you have to pay for the compute day and day, and the maintenance cost is very, very high. Today, with the cloud providers like AWS, Azure, Google Cloud, the model has flipped. It's like renting an apartment instead of building the house. You don't have to own the bricks, you just have to pay the rent. You rent servers, databases, storage, and form a massive provider. You pay only for what you use, just like your electricity bill. And the best part, if you need to more power, you don't wait 6 months. You just click a button and you have it in minutes. So why does the whole world use someone else's computer? Why do we rent a machine on someone else's infrastructure and not our own? First thing, let's say today your e-commerce website is expecting around 1,000 users or 2,000 users per day, but the app is functioning perfectly fine. And now you have a Black Friday sale or you have a Christmas sale going on the next week, or one of your product boomed a lot. Then you will be bombarded with unexpected amount of traffic on your website. It will reach millions. Your APIs will start overloading. Your database will start overloading. Instead of to make it flexible and scalable, cloud provides you um, very nice framework so that in one click you can horizontally or vertically scale your compute resources. The second most important part is you don't have to pay once, or like you don't have to pay prior to your usage. You pay as you go. You only pay for the compute which you use. Nowadays it is more popular with the serverless architecture with like AWS Lambda or serverless databases like NeonDB, etc. The other thing, as you can see, the startup space is moving really fast, especially in Bangalore, Hyderabad, Pune. All these tech industries, they ship products within weeks sometimes, and they need tools to deploy it faster, make it scalable. So cloud platforms like Vercel itself make it really fast. Now, let's talk about the elephant in the room in the space of cloud providers, the AWS. AWS provides more than 200 services to enterprises and individual developers, be it compute for EC2 or Lambda using serverless. For storage, it's RDS, it's DynamoDB. For networking, VPC, Route 53, load balancers, everything. AWS has placed itself in such a way that it is very hard to move on from that particular product. AWS has made the world its infrastructure. So I'll just speak about how the global infrastructure is split up for AWS. So AWS has split up world into regions like US East 1 in North Virginia or Asia Pacific Mumbai, each containing multiple availability zones. So there are at least 2 or 3 availability zones in each region, which offer compute and act as data centers. The reason for them being multiple is if one fails, you can fall back to another. And the applications which utilize multiple availability zones are usually more fault tolerant because when one fails, they have a fallback ready to replicate that data with low latency. The third thing are the edge locations. So there are more than 700 data points spread across cities, which act as cache providers, as small computes to send data between the servers, which reduces the round trip a lot. So let's say today I'm opening a website which has many assets. It has big images, very good animations, and the website is hosted very far away from my current computer location. Every time when people like me will open that website, there will be a very big round trip for the data, and the latency will increase. What edge locations provide you is whenever the data is sent to the user, the edge data center caches it, and whenever the next time you request it, it serves it from the cache, reducing the latency by like hundreds of milliseconds. Now, before we move on to disasters, we need to understand how we build software on this infrastructure. Historically, we built monoliths. Imagine a giant block of stone, your logging screen, your payment processing, and your notification emails were all carved into a single block of code. But today, we use microservices. This is a cloud-native way. Instead of stone block, think of Legos bricks. We build a small independent service just for payments, separate one just for search, separate one for login, and the payment service keeps working. It is safer and faster to update, and it fits perfectly with the cloud. Let's say your client-facing service experience a lot of load. You can horizontally scale them, maintaining a stateless architecture instead of just bloating away your existing monolith. Now, with these basics in keeping in mind, we'll move to the AWS outage which happened recently. It's 6:49 a.m. UTC on October 20. The internet did not break because of a DDoS attack. It did not break because of a fiber optic cable. It was just a tiny internal automation error, a process that updated a record in wrong order. The root of the issue was in US East 1 region of the AWS, which is the oldest and largest region hosted by AWS. But the impact was not contained there. The blast radius was very, very long. So the down detector, which is used for checking the status of every application through a website, reported 17 million user reports worldwide. More than 3,500 companies tracked by down detector experienced elevated disruptions, with 19 still facing issues the following morning. There were reports all over from UK, US, Germany, Netherlands, Brazil. The most affected services were Snapchat, Roblox, Amazon Retail, Reddit, and so on. You can see in the graphs the outage reports and the services which were struck the most. So these services are very crucial part of our daily life, and if they fail one by one, it is a cascading effect and the entire economy faces destruction. So I'll come to the issue which caused this outage. So DynamoDB is a service provided by AWS, which is a serverless NoSQL database. DynamoDB is used internally by AWS as well as the clients or the enterprise use DynamoDB to store its data and serve clients. There are two components in DynamoDB. The DNS planner and the DNS enactor. Consider DNS planner as a monitor which considers the load and routes traffic accordingly, creating new DNS plans for each service endpoint. And the DNS enactor, it applies the new plans and removes the old plan. It operates independently across all the availability zones. So now the race condition. The race condition involved an unlikely interaction between two of these DNS enactors. One DNS enactor began applying an older plan, but experienced unusually high delays. These delays could be network traffic, timeouts, anything. While it slowly worked through the updates, the DNS planner continued producing newer plan generation. And the second DNS enactor then picked up one of these newer plans, applied it rapidly, and then started a cleanup process. At the same time, the old DNS enactor, which was very slow, finished applying its plan, but due to the order of the events being swapped, the full plan which was supposed to be active was removed away, leaving DynamoDB with empty DNS records. And empty DNS records means there is no way of communication between services. No service can find IP address just because DynamoDB does not contain it. So let's consider what DNS exactly is and how does it work. So what you might have heard a lot, what happens when you type google.com, what happens when you type chatgpt.com in your website. First, these are just the domain names which are human readable, but machines don't understand this. They are bound to a specific IP address which serves the content of the website. The user asks DNS resolver, what is the IP address for this domain name? The resolver step by step contacts root DNS server and then appropriate TLD servers like .com, .in, and then the authoritative name server for that specific domain. The resolver then sends the IP address back to the user's device. Now, user's device caches it, so that whenever I visit the website again, it won't have to go through this whole process again and again. Only when the cache is invalidated, it can check the DNS again. Then the HTTP protocol gets the web page with the following flow of the events. But why is the DNS so important? We consider DNS as an internet's nervous system, because every action happening here, you open a website, you send a request to LLM, you send request, the internal services communicate with each other through IP addresses. When the DNS breaks at scale, it can ripple across thousands of apps and millions of users in minutes. So just like in your body, even if all your organs are functioning, but if you cut off your nervous system or your nerves, your body can't coordinate because it has no way of communicating with each other. On the internet, DNS carries the signals between users, apps, to where to carry the signal and where the service may be healthy or may be unreachable. So the core idea which happened was DynamoDB removed all the records of the DNS data. The services could not reach their IP addresses, due to which APIs, backends, and the resources went offline. In this diagram, you can see the dependency chart. So here is the DynamoDB, which is the root cause of failure. And here is the DNS. These services provided by AWS, the EC2, Network Load Balancer, and Lambda, even the management console and the IAM, depend on direct DynamoDB for storing its metadata or credentials. The first thing which happened was all these, the EC2 machines which were already running, they kept running seamlessly. But any new EC2 machine starting to fail because it could not find the IP addresses. The network load balancer, which manages the traffic between all the other machines, could not connect to the EC2, and it became a cascading failure. The Lambda is a serverless platform, but it depends on EC2 and network load balancer internally for its functioning, due to which even Lambda failed. And people could not log into their AWS console to raise a ticket or to have customer support also, because IAM uses DynamoDB to store its credentials and store the roles and permissions. So this shows, like, this is a classic example of single point of failure and cascading failures. Yeah. So why this was so dangerous? This was not a traditional outage, but it was a control plane failure. The infrastructure was running, the data was intact, but the system responsible for coordination, recovery, and authentication were unavailable. Because AWS's services are deeply interconnected, the failure of one of the foundational services rapidly propagated across the region. So now we'll move on to the Cloudflare incident. You must have seen this particular spinner in most of the websites which you visit. Cloudflare is a provider to provide mostly DDoS protection and to avoid malicious traffic into your websites. What happened in Cloudflare was on November 18, there was a database configuration file that disrupted the core service, which was responsible for its core proxy services. So the architecture which Cloudflare uses is pretty different. Cloudflare runs its checks in all the edge locations. So it utilizes the same box of service or same set of rules and applies it to all the edge locations. That means uh, each malicious request is processed by a different server and not a central server. Because they contain the same code inside, even if there is one fault or one wrong line of code in that block, all the edge locations across the world will face the same issue. That is the trade-off which Cloudflare has made by its design. So because of the Cloudflare incident, thousands of edge locations simultaneously went down. The HTTP proxies, the Cloudflare workers, the security and bot management features, everything started to fail. Due to this, all the websites who use Cloudflare as their first wall of protection, like ChatGPT and Spotify, Twitter, Canva, everyone faced financial losses because there was no way people could log into that website. You can see the amount of cost this downtime of 3 hours has produced. Only 3 hours and so many losses for these big giants. So what these two incidents reveal about our world? Both the incidents were DNS related, both were automation or configuration error, and not due to a wrong or bad code. Both incidents caused widespread internet disruptions and showed how dependent the entire internet is on these handful providers. And just imagine, because the electricity grid in your city went down, there would be the traffic lights would not work properly. The hospitals will switch back to backup generator. The societies will switch back to generators. So all these failures have a very cascading effect. And it is very important as an engineer or as a DevOps engineer to prevent these in your systems, or to learn how to have a graceful degradation, or to keep your systems intact even if one critical part of your entire service is affected. So the first topic which I would like to cover is exponential backoff. What I would like to ask you, what would you do if a service is erroring out? Like website is not working. You keep retrying. You press the retry tab, so you hope that it loads again, right? So this is what the basic funda is, but there is a twist here. We have to take care of a retry mechanism. Not all errors are retryable errors. Let's say you move to a wrong URL, which does not exist. It will give you a 404 error, a client error. A client error will not get success even if you retry it. But a service error like a 503 or 500 errors, they may resolve if you keep retrying over the time. But it is very important to understand at what timings you retry. So there are 3 ways. The constant backoff. You wait for the same amount of time and retry, but it is ineffective because you're just bombarding the service with more requests instead of giving it time to recover. The linear backoff. The wait time increases linearly, 1 second, 2 seconds, 3 seconds. This is also not much helpful in scenarios because still you have a constant pace of backing off. But exponential backoff, in this case, you increase your delay time by factors. So usually it is a factor of 2. So for 1 second, then 2, then 4, then 8. This way you are giving space for the service to come back healthy and then serve you the request. But imagine a scenario where one service is down and 10 services are applying exponential backoff. They will retry at the first second then all 10 will retry at the second, then the fourth, then the eighth. Basically, they all are cumulatively sending requests all together to that service, which is still overloading the service. That's why this is called a thundering herd problem. To avoid this, you can add a jitter. So a random deviation for your delay, so that all the services won't send requests at the same time, but there will be some delay and there will be some randomness added to it. The second thing to make it more advanced is circuit breakers. So think of it as an electrical circuit only. What happens when a circuit is closed? The light bulb glows, right? And when we turn off the switch, the circuit is open. There is no electricity flowing in it. The same funda you can apply in a microservice architecture as well. Let's say your payment service is throwing 500 errors. You know that payment service is down, but your users are still opening the payments app, hitting the payment service, getting the error back, and you are showing it to the users. Instead of bombarding the payment service with so many client requests, if you know that this service is down for some period of time, you can just say the user, hey, please wait for some time. This will be back up. So I'll just explain the flow chart of the circuit breaker. The initial state is closed. When the requests are going fine, it is a success. The state remains closed. If it starts failing and it fails over a threshold, let's say 50% of the requests fail in 1 minute duration, then you can set the circuit as open. That means your all other services will know that this particular point is a point of failure, and then the cooldown period will start. In the cooldown period, the circuit will stay open and move to a half open state. The half open state is like a testing state. If a request is passed through a half open state, the circuit again gets closed. But if it fails, it again gets to open and the cooldown period starts. In this way, you are protecting compute costs, you are protecting API, and you are preventing from your logs being bombarded with error messages. The third thing is a containerization. Most of you must be familiar with it. Docker is the most popular way to containerize for a beginner as well. So why do we containerize applications? Containers are lightweight portable units that package application and its dependencies to ensure it runs consistently across different environments. Like virtual machines, unlike virtual machines, containers share the host system's kernel and resources, which makes them more efficient and faster to start. You have your repository. You package your code into a container using a Docker file. In your CI/CD pipeline, you said that, okay, this is the image which I want to push to my registry, and you can pull that image anywhere in physical VM, virtual VM, private cloud, public cloud, anywhere. So when the AWS incident was happening, you see where the failure was lying. It was lying in one particular region getting blacked out. But what if you have a multi-region deployment? So my database would stay close to my so let's say my database is close to my users in Mumbai, but what will happen if it fails? Like, if that is my single source of truth, what if that fails? My whole system will degrade to unusable condition. We should not design applications to have such a critical fall. Instead, we should allow services to work with degraded resources, but still it's working, right? So you can have multiple deployments of database in another region, so that we can replicate the data, get your data back up instantly, and your users won't face much of a downtime. So one company was saved because they had a multi-region deployment in US East 1. It failed. They replicated the data in EU West 1, which was working. So they could access the management console, while the rest of the people who had a single region deployment, they could not. But if it is so easy, then why don't people do it? There are some trade-offs which we need to keep in mind while applying a multi-region deployment, like availability, latency. For distant regions, there will be a higher latency. The cost of infrastructure in multi-region deployment is very high, and the data consistency is very hard to manage. You will have to write migrations. You have to maintain the same state of data in every replica, which is very tough to manage in large scale. The deployment speed also gets reduced because you need to ensure in your pipelines that all the regions are served with the correct data, there is no error. And if there is an error, you have to roll back within one command so that all are back to the same state. We talked a lot about errors. We talked a lot about how the services communicate with each other. But as a developer, how would you know that this is the point of failure? The way AWS and Cloudflare's team acted for these outages were very interesting. Because they have such a nice setup of monitoring and observability, it is easy to track down the root cause of the failure. So there are three pillars which you need to take care of: logs, metrics, and traces. Logs are the historical data of the system's events, errors. It can be in any form, text, or it can be structured, stored within high performance DBs. Metrics are numerical measurements of system behavior such as CPU, memory usage, error rate, number of redirects, any metric which you need for debugging. Traces are representation of individual request flow. So what happens within that session? That a user from VIT Vellore opened this page, he did these actions, then he closed the system. All these actions of individual users are contained within traces, which performs a really fine-grained view for a developer to understand what was the cause of error. The tools which you can use for this are open source tools like Grafana, Prometheus, Jaeger, and OpenTelemetry has also set a uniform standard to integrate observability in your applications. Coming to the CI/CD pipelines. CI/CD pipelines stand for continuous integration and continuous deployment. The basic flow of a CI/CD pipeline would be a developer writes code, he commits, the build is successful, then the pipeline would test the code. If it's passing all the tests, then it would push it to the staging, and then if we ensure that all the tests are passing, it is looking fine, we can push it to the deployment to the front users. So, but why CI/CD pipelines, right? You can do this manually, you can run tests manually, staging. It gets very hard to manage in a huge team and with the huge amount of services as well. Human cannot detect all the errors. We have to accept that. We have to write tests. Even tests sometimes are insufficient, which some errors we get only in the production, but writing tests, writing deployment scripts really reduces human labor. It reduces cost and speeds up the deployment quickly. Like Sir mentioned, Agile DevOps includes a good amount of CI/CD pipeline scripting as well. So now, before coming to the future trends, I will just show quick demo of all these points which I've covered. I'll just join from another device. 1 second. Am I audible?
Yes.
Loud and clear.
Yeah. Okay. So, can you see the screen?
Yes.
Okay, so I had just prepared a simple demo repository in Golang for these topics. I'll go through it one by one. So the first thing which I would like to show you is the linear backoff or the naive way of doing backoff. Here I'm running a HTTP server and I will just take in error responses from it. You can see here all the requests are being retried immediately. We are not giving any time to the server to recover. In the second demo, I will show you what happens when we use exponential backoff. We give the time to the service to recover. Yeah, you can see here we are waiting 1 second, 2 second, 4 second. And this part, the service is recovered. So we sent much less requests and we got the service back up as well. So this reduces the load a lot at scale. This is only a one service, so you might not feel that it is important, but at scale, this is really, really important. Now I will show you the circuit breakers flow. Okay, here you can see the requests are being sent. The current status is closed, service is healthy. Now what will happen if I toggle the services nature? I will toggle to a failure state. Now the service is failing, the status is still closed, and after reaching a threshold, we can see the system is in open state and cooldown period is started. The circuit went to half open state, and because the service is still failing, it remained in open state. Now I'll just make it healthy. Yeah, the half open period was very short and the request passed through. So we now got the service in back to closed state and the successful requests are increasing again. So I hope you understood how the circuit breaker functions and how it improves other dependent services to handle errors. Now I'll just show you a demo of containerization and using infrastructure as code. infrastructure as code basically means when you use AWS services, when you use Azure services or Google services, you manually go to the management console, you select these resources I want to deploy, you make the resource, then you come back to your code and write the configuration and deploy it. But this is not scalable, this is not efficient. Big teams cannot rely on it because usually one person does not control all these things. You have to have set pipelines for coding as well. So I've created a simple Terraform file here. What I will do is I have made a simple HTTP server. I will build it using a Docker file. I will push it to AWS's container registry. I will tell my EC2 to pull the image of the container image and run my application on a public IP hosted in the EC2 machine itself. I'll just give you a glimpse of this Terraform file. So here we just define our providers, which is AWS in the region US East 1. We create our ECR repository for keeping our images, which we'll call it containerization demo. We'll get the Linux Amazon image for running the code. We'll add security groups as well to allow the input and output ports for this particular ECR. We'll add an IAM rule for EC2 to access ECR. So it is a good practice to keep your services restricted, to keep a track of what other things they can access. So in this case, my EC2 can access ECR, but it may not access it can access a containerization demo repository, but it may not access another repository. You can add those rules as well. Then you create a EC2 instance here. You just install Docker in the EC2 instance. You set the region, you pull the latest image from the ECR repository, and you run the container here. So that was about the Terraform file. I'll just run it again. I'm just building the container locally just to check if it's working correctly or not. You can see the server is started on port 8080. And so now we can push it to our AWS. So here we just initialize our Terraform file. It will generate a plan for what it needs to do. As a developer, you can view the plan and check if anything is wrong and edit it. You can view the plan which Terraform has generated using the Terraform plan command. Yeah. So it says 6 things to add, 0 to change, 0 to destroy. And we have configured it to give these output: EC2 public IP, repository URL, and the SSH command. Now I will push this code, create a repository and push this code first to the AWS, then it can access it. So here we have targeted a particular resource called AWS ECR repository and we'll build it. It says one resource added and we have got the ECR repository URL. We can go here and check in our console as well. So if I go to the repository section, yeah, you can see it is added on 8 p.m. and 7 minutes. So this is our current repository. It does not contain any images as of now because we haven't pushed it. So we'll just push it now. Here I'm just authenticating my ECR with my region and my login, which is username would be AWS by default and password would be my ECR registry. The ECR URL is this URL from the output here. Yeah, you can see we have pushed the image in our repository and now this can be accessed by our EC2 machine and run it. So now we just have to run one command. What this will do is it will take, pull the image from the repository, install Docker in the EC2 machine, pull it, then it will run it. So it will take some time to completely run and have it on the public IP address. So this is the public IP. I'll just try to. Yeah. So we can see if I send the request to this public IP, we can see that container is running. If I just copy this. And we hosted our application on port 8080, so we need to specify that. Yeah, we can see hello from the container. And for the health endpoint, we can see the health is okay. So this is just HTTP connection. We have not added a HTTPS Nginx proxy, reverse proxy to it, but you can add that as well. And so now you have created 6 resources. You have created a ECR repository. You have created this image as well. You have created a EC2 instance. You have created roles, security groups. If I go here, EC2. I can see your US East one instance is running for me. Yeah, this one. So now you have applied all of this, but you have to now remove it. Terraform gives you a really simple way of destroying all the resources which you created gracefully, which is just Terraform destroy command. This should delete all the data which we created through the script, and our account will be back to the normal state. Yeah. So all the resources which we created are now deleted completely. Yeah. There is no EC2 instance running here. You see, this is a very easy way to have your tests, development, or your CI/CD pipelines for your team to deploy and manage apps very seamlessly. In this repository as well, I have added the workflow file, which what basically does is it will, whenever I push a commit to the main branch, it will do some things. So the first thing it will do is download dependencies. It will verify the dependencies in my application, which is very important for security. This is a very simple go mode verify command, but there are other providers which lets you scan your entire code, check if there are any SQL injections, malicious scripts in the code base, and it will stop the deployment pipeline. Then it will run the tests which I have developed, which I've added here. So in package, the circuit breaker had some tests. The mock service also had some tests here. It will run all those tests, and if all the packages build successfully, then only it will push it here. You can see in the actions the previous workflows which failed. Yeah. Here it failed because I had set a threshold that all my tests should cover 80% of the code, but here it covered only 60%, so that's why this build was failing. Test coverage is also very important metric for your application. It basically tells you how many code paths in your application run for those specific scenarios. Basically, the more test coverage, the more robust your code base would be. That was for about the demo. I'll just move to the presentation again. Yes, so coming back to the last part of our session, the future trends. You heard a lot about edge computing in this session. So what exactly is the edge? So the cloud layer works in a server distant from a user, but some small services or small telemetry data needs to be collected from automobiles, from IoT devices, and these needs to be processed close to the user itself. So edge computing lets you provide your compute close to the user, cache data, and reduce latency as well. which has much more benefits like improved data security. Most data is processed and stored locally. The data sent to data centers can be encrypted. Remote data collection. Collecting data from locations with poor connectivity is challenging. Edge computing enables the data collection and transmission from remote sites like oil field, industrial zones, and offshore vessels. The second thing would be the zero trust security. Earlier in systems, it would be like if you are part of the system, or if you have crossed one barrier of entry, then basically you have access to everything. But the zero trust flips that idea. Every user, device, and request is treated as potentially untrusted, even if it originates within the network. In short, you should never trust, but always verify. Access isn't given because of where you are inside the office, but because of who you are and what you are allowed to do. The AWS IAM is a great example for this. It provides very granular security policies to its users and to its services as well. It is important now because cloud is everywhere. Every application is deployed on AWS, GCP, or things. Remote work, employees connect from home, they don't stay in office. Compliance and visibility. Enterprise needs full audits as per request verification. And post-outage world. After massive incidents in 2025, firms now prioritize resilience plus security together, so that no critical point can be taken down with ease. That was the overall session. I'm open to any questions if you have.
Thank you, Tejas, for such an insightful and practical session. We will now move on to the Q&A session. Participants are requested to post their doubts in the chat box or feel free to ask questions by unmuting themselves.
Secretary, I don't have any question, but I want to appreciate both of you.
Thank you so much, sir.
Manya and Tejas, wonderful
Thanks.
job. Really proud of his students like you. Very good job done. Very good job done. I'm really very delighted to see both of you doing excellent job. So I have no question, but very sincere appreciation of your efforts. Continue doing good job. Continue doing good job.
Thank you so much, sir.
Manya is from side school only, sir. Score school only, sir.
They are all VITians.
Yes, sir.
Yeah, because still, I don't remember after 2009, October, when we school got divided. Even still now, I cannot differentiate, because when I was in charge of the school, that time we had only one school.
Okay, yes,
School
sir. Yes, sir.
computing
Yes,
science
sir.
only. So I cannot remember who is in what school. For me, everybody is the same.
Okay,
And
sir.
I cannot remember that who is in site, who is in scope, or whatever thing. It is not possible for me to remember. I cannot differentiate, because for 5 years I was in charge of combined school, and that time everybody was really for me like my own colleague, friends. So I cannot find the difference. Yeah, it's a great job done by all of you. Really, I am very happy. Very happy. Yeah, so nice.
Manya, please, if no questions, we'll go for the next session and then we'll continue.
Tejas, maybe you could give an overview about what students need to focus on if they want to get into cloud computing and DevOps. Any sort of certifications are available, or how they need to go about, what sort of opportunities are available for them if they want to specialize in these two areas.
Yes. So my first recommendation would be to learn about applications, like any application which you want to develop, be it app development, Android, iOS, or websites, front end or back end, doesn't matter. To understand what DevOps does, you should be able to build applications. The second thing, like Sir mentioned, the courses are available. The most prominent one is the certification provided by AWS for cloud practitioner, and for more advanced people, it is the AWS security, I think. So you can focus on these courses, but in my personal experience and what I've seen my peers or seniors doing, they just make stuff, they break it on the cloud, and they learn from it again and again. So AWS and GCP provides ample amount of credits for students. You can use up those credits, um, deploy basic applications, and then you can include some ML servers as well. In this way, you will be able to grow and practice security in your pipelines as well. In my demo, it was not there, but having a good, secure cloud environment is really important.
Thank you, Tejas.
Thank you, sir.
Any other questions?
Okay, Manya, you can give your contact details so that people who have still questions, they can contact. You can go to the next session, please. Next agenda of your session.
Okay, I think Abhinav has one question. His question is, do we need to know a cloud platform like AWS before learning Terraform?
To understand what Terraform does, basically you saw it creates resources, it adds permission. You must have a conceptual idea what AWS or what GCP does internally. If you know that, you can write Terraform scripts. So yes, I would say you should know cloud platforms before learning Terraform.
Okay. I don't think there are more questions. Thank you so much, Tejas. Your discussion provided a valuable real-world perspective on cloud technologies and DevOps workflows. To formally to form to formally express our gratitude and conclude today's event, I now invite Webhub Chairperson CSI-VIT Vellore to deliver vote of thanks. Over to you, Webhub.
Yeah, thank you, Manya. I hope everyone found this session very insightful and impactful. As we come to the close of this session, I would like to take a moment to express our sincere gratitude to everyone who made today's webinar possible and truly impactful. First and foremost, we extend our heartfelt thanks to our chief guest, Mr. P.R. Krishnan, for taking the time to join us and for sharing valuable insights drawn from his vast industry experience. Sir, your perspective on technology, leadership, and large-scale digital transformation gave us a broader and more practical understanding of where the industry is headed. We are equally grateful to our guest of honor, Professor H.R. Vishwakarma, for being with us today. Your continued support for the various student communities of VIT and apart from VIT help us contribute to technology-driven innovation, and you truly inspire us. And your presence and encouragement means a great deal to the CSI community. I would also like to thank our faculty mentors, Professor Senthil Kumar and Professor Govinda K, for their constant guidance. Your support empowers us to take initiatives like these and continuously improve as a student chapter. A special thanks to our resource person, Tejas Ghatte, for delivering an engaging and insightful session. The clarity, real-world examples, and relevance of your talk made this session extremely valuable for all of us. My appreciation also goes out to our distinguished CSI members present on this meet today, who worked behind the scenes to ensure the smooth execution of this webinar. Finally, thank you to all the participants and attendees for joining us today, actively listening and engaging during the session. Your enthusiasm is what keeps the CSI community alive and growing. With that, we conclude today's webinar. We hope you found it insightful and relevant and we look forward to seeing you at our future CSI events. Thank
Just to
you
add
and
up
have a great rest of the day.
Sorry, just to add upon, I would like to extend our appreciation to our student speaker, Tejas, for such a well-prepared and insightful session with clarity, confidence, and technical depth, and also for explaining the concepts with real-life practical examples. I'm sure that would have made learning engaging and relatable as well. And our sincere gratitude to our chief guest, P.R. Krishnan, and guest of honor, Professor H.R. Vishwakarma, for gracing the event, sharing valuable perspectives, and inspiring young minds with their guidance. A special thanks to our MOC, Manya, for anchoring the session gracefully, and to the entire VIT team for their coordination, dedication, and smooth execution. Your presence and participation added immense value to the event. We invite you to join us every fourth Saturday for more student-led, insightful technical sessions by passionate young minds like our Tejas today. We look forward to seeing you again. Thank you and good night.
Rightly said, sir. Thank you.
Thank you, sir. So I
Thank you, sir.
extend my thanks to Subramanian sir and his team. His initiative for all these things.
Thanks,
Yes,
sir.
Thank you.
Actually, the real motivator is Mr. R. Saravakumar.
Okay, sir.
Okay, then okay, we all found it now because it is always nice to engage young students, right? Young and bright minds.
Yes,
And the
yes, sir.
session was very good actually. Mr. Tejas gave an excellent
Yeah,
talk.
it's nice. Tejas.
Very
It
nice
is
talk.
really
And it was also nice to have Mr. P.R. Krishnan and Dr. H.R. Vishwakarma on the stage. Of course, we always have Mr. Govinda's support and your support. And along with Aguilar, Dr. Aguilar, and Mr. Sarvana Kumar and all. Actually, it's really good actually. So, as Mr. Sarvana Kumar said, no, we have to encourage young speakers, on every fourth Saturday. Different chapters will be hosting this student-led webinar because every chapter should have a chance and every chapter should encourage their young students. So that is the idea. So if some chapter is not able to host it, then other chapters can pitch in actually. So that this continues. No, we don't want to break it actually. So anything, Dr.
Sure, sir.
Yeah, anything, Dr. Aguilar, you would like to add actually? So, Govinda sir should say some few words.
Yeah, thank you, sir. Thank you. Yeah, it is a right platform where students can share their knowledge and then exchange with other students also. We'll continue the same thing every fourth Saturday. Sure. Thank you, sir.
Thank you. Bye, sir. That's all from my side.
Thank you also. Thank you also.
Thank you. Bye.
Thank you, Sendil sir.
you, sir.
Thank you, Manya. Thank you, Tejas. Thank you, Vaibhav. Thank you.
Thank you,
Thank you, sir.
everyone.
Thank you.
Thank you so much.
Thank you.